Hi, and welcome to the video, Understanding Color Spaces and Applying Grayscaling. So firstly, what exactly are color spaces? Well, have you ever heard of the terms RGB, HSV, or CMYK? Well, if you're into professional photography or printing, I'm guaranteeing you've heard of these terms before. And what these are the names of color or very popular color spaces. And color spaces, also known as color models or color systems, all refer to mathematical models used to describe colors. So why do we need color spaces then? Well, as I just said, color spaces are needed to represent color. There are different ways we can actually have different parameters or different contributing factors that give us the color we want, okay? So different color spaces offer unique features, and those things are like for different applications like printing or for representation in computer vision or for photography. So the one we're dealing with, the most common and popular one in OpenCV is RGB. Oh wait, it's actually BGR. And that's just a funny little thing in OpenCV where we do use the RGB color model, which is popularly known as colloquially in different systems. However, the order OpenCV stores the colors in is BGR, blue, green, and red. So that's our default color space in OpenCV. And it's also an additive color model. And what does additive mean? It basically means we have different intensities of red going on the scale from 0 being the darkest, to 255 being the brightest. So we have different contributions of red, green, and blue that give us the color we want. So you can imagine we can get yellow by having different intensities here. We can just get red and green and decrease blue entirely, and then we get yellow. And that's how we get colors from the RGB model. And just a note here, OpenCV actually stores it in BGR format, which I refer to here. So now let's talk about the HSV color space. Now this isn't as popular in computer vision. However, it is very useful when you want to actually filter specific colors in a computer vision application. So how does it represent color? Now the additive model in BGR is quite self-explanatory, and you would have done this basically if you were doing art or painting as a child or as a student in college. However, how does HSV work? It represents ways humans perceive color. However, that doesn't help us too much because we need to take a look at the model cylinder here. So imagine we have one parameter being hue, and hue is essentially the color value, and it ranges in a scale from 0 to 179. We have saturation, which is basically how rich the color is here. So you can see it gets kind of pale here in this axis. Then as we go further along the saturation scale, it gets more vibrant. Value here represents brightness. So that's the z-axis in all of this. So as you can see, we go from lighter to darker as value goes from low to high. And hue basically is a color. So by changing saturation and value, and hue is how we get different colors using the HSV model. So HSV, like I said, allows color filtering, unlike RGB. Now, it's possible you can do color filtering on RGB. However, it's very, very difficult, and it's no point because HSV is so much easier. As you can see here, if you ever wanted to filter the red colors, you have a filter on hue scale from say 15 to 165, just a small range right here. Green is quite simple here as well. It's 45 to 75. Blue is around roughly 90 to 120. So as you can see, HSV lends itself perfectly for color filtering. So what about grayscaling? When we say an image is grayscale, we basically are talking about a black and white image. However, black and white images are not just black and white. They're comprised of shades of gray. And in OpenCV, a grayscale image is even simpler to represent because it's not three-dimensional. It's effectively two-dimensional. So imagine we have a grid here. This is handwritten number 1 here. So if you were to represent this in grayscale, as you can see, every pixel here has a value. With number 255 being the brightest, that's white. And the lower you go on this, as you can see, like these values here are quite dark. You can't even see the numbers here because they're almost black. They're much lower in value to 255. They're 91 and 68 here. So that's how grayscale images work. And it's basically, as I said, just a two-dimensional grid where every pixel here has a value that represents the intensity of the level of gray. So just to quickly summarize what we've learned what exactly are color spaces, and we've taken a look at the RGB, that's red, green, blue, and the HSV, that's hue, saturation, and value color spaces. So now let's go into OpenCV and actually play with some color models and do some grayscaling on some images as well. Thank you.